We have a sample problem here. A 1.5 centimeter tall object is 20 centimeters in front of a concave mirror that has a 1.2 meter radius of curvature. Calculate the position and height of the image. State whether the image is in front of or behind the mirror and whether the image is upright or inverted. I've also copied or pulled out the table from the test notes that has down here at the bottom the plus and minus sign designations, positive and negative, which we'll use in making sense of our answers. So our object is 1.5 centimeters tall, so this will be H. The object is 20 centimeters in front of the mirror. This is S. We have a concave mirror. It has a radius of curvature of 1.2 meters. So if we come down to this table, mirror radius, if it's a concave mirror, it's a positive radius. So when we talk about the mirror focal length, the focal length F, I'm going to write this at the top, is R over 2. We've been given R, the radius of this mirror is 1.2 meters. So the focal length is 0.6 meters. And this is considered, so back down to the table, positive, this is a positive focal length. Now, in terms of relating object position, image position, and focal length, we have this equation. So 1 over S, where S is the object distance, plus 1 over S prime is the image distance, equals 1 over F. So we're trying to find out where the image is located. So I'm going to, oops, not equals. I'm going to bring the 1 over S to the other side. So we know F is 0.6 meters. S up here is 20 centimeters. So we'll actually want this in meters. We could put them both into centimeters. That's fine. We just need to be consistent with our units. So I'm not going to take the time to find a common denominator. I'm just going to plug it into my calculator this way. So recall we get this is 1 over S prime. And so once we calculate this side, we have to take 1 over that. So I just put it all in my calculator at once. 1 over that stuff. So I'm getting negative 0.3, and technically it would be significant to 2 places since we have 2 significant figures in the problem. All right, so we want to make sense of this answer, and that's part of the question. That's partly why it says to state whether the image is in front of or behind the mirror, and then whether the image is upright or inverted. And we still need to find the height, which we'll do in just a minute. So S prime being negative has a specific meaning. And again, this table at the bottom is going to come in handy. So we just came up with a negative answer. We are talking about an image distance, S prime, for the mirror. So since we came up with a negative answer, that means this image is virtual, but it also means it's on the opposite side. Now that means the opposite side of the mirror compared to where the object was. So this opposite side means behind the mirror. So we can say this image is 30 centimeters behind the mirror. So our object was in front, the 20 centimeters. Our image appears back here, 30 centimeters away. Now, it will be upright, which I'll show you, and it will be magnified. So let's calculate that as well. Magnification. So the equation for magnification that gives us the positive or negative sign is this negative s prime over s. So s prime is negative 0.3. So there's a negative sign in the equation itself. And then we have to put the value we came up with for s prime in. And then s, we get a positive answer of positive 1.5. There are no units on this answer because this 0.3 was in meters, this 0.2 was in meters. Those units cancel. This answer, the positive sign alone, regardless of what the number is, if we come back to our table, I'm going to kind of erase some of the things I've already drawn. We just came up with a positive answer. This bottom row is for magnification. So if this equation gives us a positive answer, this image is upright, which also means it's not inverted. So just like when you look into your bathroom mirror, you see yourself. This one is a little different in that your image you see is going to be a little bit bigger, but you'll still see your head on top, your feet on bottom, upright. Now the other portion of this question is that it asked for the height of the image. And that comes from knowing the absolute value of the magnification and the height of the object. So I'm going to come over here on the left. Absolute value of the magnification is the height of the image over the height of the object. So everything with a prime is relating to an image. So absolute value, just the numerical value of the magnification times the size of the object, will allow us to calculate for the height of the image. So we came up with 1.5 for the magnification. The object itself, given in the problem, was 1.5 meters tall. 1.5 times 1.5, 2.25 meters tall. So since we have 2 sig figs, we would say this image is roughly 2.3 meters tall. So it's not meters, oh dear, centimeters. Sorry. So the image is 1.5 times bigger than the object was. That's what this means. So when we're talking about magnification specifically, the sign is completely telling us whether the image is upright or inverted. In this case, it's upright because we got a positive sign. And then the number relates back to the size of the image. Ultimately, probably the most challenging part of these questions is understanding and using this table. So I highly recommend using this table as you are solving problems so that you can make sense of the answers you're getting.